My name is Wim Michiels. I'm a principal engineer at Roku, working in the media team, and I would like to highlight two player features today, pre-buffering and playing live streams with low latency. So the agenda for this presentation. So we're going to start with pre-buffer, give an introduction what it is. Then we will explain the various pre-buffer modes, single pre-buffer, as well as parallel pre-buffer. And we will end the pre-buffer section with an example showing how applications can use pre-buffer. And then the last two slides, we will talk about playing live streams with low latency. So let's start with pre-buffer. So what is pre-buffer and why applications should use it? So pre-buffer allows applications to prepare content in the background while the user is navigating the UI. An application should use it because it significantly reduces the video start time that the user experiences. So here we give a few examples where an application can use pre-buffer. So for live streams in an EPG, applications can pre-buffer an item while the user is navigating the EPG, or an application can pre-buffer when a user is navigating the content grid, or even when the user is on a detail screen, an application can also pre-buffer a stream to play. So pre-buffer is not new. It has been around for several years and is currently used in TRC, the Roku channel, to successfully reduce the video start time from 3 seconds or even more to just 350 milliseconds. So it's a very nice feature, and it's really nice for the user to be able to press play and then have playback start immediately. So diving a little bit deeper in how pre-buffering works. So starting with single pre-buffer. So an application can give a pre-buffer command to video node, and at that time the player starts fetching the manifest as well as the DRM and the media data, and the player even prepares the decoders for playback as well. If then later the user selects the item to play, the application would give a play command, then the player would just have to unpause the decoders and playback would start immediately. And at the time the play command is given, the player also resumes fetching the media data. So as you can see, the user experienced video start time is just this little orange portion, which is a lot less compared to the whole yellow portion with regular playback. So pre-buffer, single pre-buffer, as well as parallel pre-buffer, which I will explain next, is supported on all Roku platforms, and it works for both VOD as well as live streams. There is a difference though for live streams. So for live streams, when the channel is playing from the live edge, the player does stop fetching the media data after 40 seconds or so. And we do that because we don't want to waste the user's network fetching media chunks that are never played. And actually applications have an option to control that themselves. So there are two pre-buffer commands. There's a pre-buffer, but there's also a pre-fetch DRM. So when the application gives the pre-fetch DRM command, then pre-buffer will only fetch the manifest and the license, so the DRM, and will not even attempt to fetch the media. One thing I want to mention as well is that pre-buffer may impact ad render rates, especially with live streams with server-side ad stitching. So since the player is always refetching or updating the manifest, the live manifest, the backend would be inserting advertisements, and so those advertisements are not played as long as the player is pre-buffering. So the ad render rate would drop in that case, and that's definitely something you want to take into consideration. Moving on to parallel pre-buffer. So parallel pre-buffer allows an application to pre-buffer multiple items. So in this example, we have 4 streams, A, B, C, and D, that are pre-buffered in parallel. And so there are two use cases why an application would pre-buffer multiple items. The first one is because an app may not know which item the user wants to play first. And the second case is on platforms that support dual decode or multiple playback. an application may want to pre-buffer all the items that play in parallel. So there are two parameters that control parallel pre-buffer. There is the priority level as well as the player ID. So the priority level tells Roku OS which resources should be assigned or which streams should get more resources assigned versus other ones. So in this example, so if we talk about resources, so Roku OS assigns memory resources, which will be the manifest as well as media data. They take up memory. We have DRM and license resources as well as decode resources. And based on the priority level, Roku OS can decide which stream should get which resources. So in this case, we see that this platform has two decode resources. And so two streams get a decode resource, stream A and D, but B and C do not. Then the second parameter is the player ID. And the player ID tells Roku OS which items play in parallel and which play in sequence. So in this example, at the bottom here, we have stream A and C are assigned player ID 0. So these two streams play sequential from each other. But then stream D and B are assigned player ID 1. And so they can play in parallel to stream A and C. And so that's how applications can use the player ID. Then showing an example how applications can use it. So in this example, we have an application that's pre-buffering two items, a main content as well as a trailer. And so the application creates two video nodes, video node 1 and video node 2. The main content is assigned to video node 1 and the trailer is assigned to video node 2. And then the application gives a prebuffer command using the control X field. So the command is prebuffer. The player ID is 0, meaning these items will play sequential, not in parallel. And with the priority, the application is telling us that main content is more likely to play. So a lower priority number is actually a higher priority. So Roku OS will assign more resources to the main content versus the trailer. And then when the user actually selects an item to play, the application starts the corresponding video node. So that can be video node 1 if the user selected the main content to play. And if the user selected the trailer to play, then the application would start video node 2. So basically that's just giving a play command to that video node. Switching to low latency playback. So historically, Roku devices have been playing 30 seconds behind live. Playing closer to the live edge is better for the users. It gives a better user experience. People don't want to hear from their neighbor if something happened in the game they're watching. They want their player to play as close to the live edge as possible to get a good experience. So Roku OS provides two low latency modes. We have reduced latency as well as low latency. So reduced latency will become the default starting fall 2025. And it's a good balance between user experience delay and other KPIs as rebuffers, yes. And low latency plays closer to the live edge, but it does require low latency dash or low latency HLS streams. And it typically has higher rebuffer values compared to reduced latency. So low latency really prioritizes playing close to the live edge. Another thing to mention about low latency is that it becomes more challenging to do server-side ad stitching because the backend has less time to insert the ads in the manifest compared to reduced latency. If we then look at actual latency values, so reduced latency aims to play 18 seconds behind the live edge, while low latency is below 6 seconds. The actual values that we play from the live edge may be different, and we show an example here how that's calculated for a regular dash stream. So this is a reduced latency example. So for a live dash stream, we have the availability window in the manifest as well as the suggested presentation delay. And so based on those two values, the media chunks in green are the ones that the player can download, can fetch. And so in order to determine the player delay, what Roku OS does, it takes the maximum value of the suggested presentation delay, that's in the manifest, with the target value in Roku OS, which for reduced latency is 18 seconds. So in this case, the suggested presentation delay is a little bit more, and so likely the player will play like 20 seconds behind the live edge. We also have an example that shows how applications should configure the player for live playback. I mean, live playback as close to the live edge as possible. So it's very important that the application specifies a seek value of -1. If we go back to the previous slide, so you see that now is at this position, and so negative values, a negative value of -1 would be 1 second away from the live edge. But then, of course, this value is clipped against the window, the availability window, and so the player will actually start playback here. But it is important that the player, so that the channel, the application does not specify 0 as a seek position, because that would mean that playback starts as far from the live edge as possible, and that's not what we want. Yes, we want to play as close to the live edge as possible. We also show the manifest and playlist values that impact um, the final video delay. So for dash manifest is the suggested presentation delay, as mentioned before. For LL dash, low latency dash, is the latency specified in the service description field. And for HLS is the target duration that impacts the final playback delay. So it's these values combined with the seek position, combined with the target value in the Roku OS that determine the final low latency value of the player. And this concludes my talk. So I would like to thank you for your attention, and please let us know if you have any questions. Thank you.
There we go. From Kevin, what is the limit of the number of items you can pre-buffer on one player?
It may depend. Sorry. Like Roku OS will manage the resources, as we explained, and some devices with more memory we can pre-buffer more, because then we can allocate more memory to each video player. But I think typically, up to 4 would be reasonable. Anything more than that, I think, would be too much.
Okay, excellent. Will the prebuffer command node, I'm sorry, will the prebuffer command work if the video node content is a playlist instead of a single VOD live stream?
Yes.
There we go. Will the 30-second delay ever be configurable on the video node, especially for live streams?
So the channel can set the delay by using by seeking to -30 in this case. So if you seek to -30, you're asking the player to play 30 seconds behind the live edge.
Yep. All right, next question. How do parallel prebuffers affect performance?
Yeah, I mean, prebuffer in general improves performance because we can start a lot quicker. If you only prebuffer one item, then that one item gets all the resources, so that will start quicker then. So if you do parallel prebuffer, and then Roku OS will kind of share these resources a little bit, and then depending on the priority, then if the user selects an item that had lower priority, it may start a little bit slower versus just prefetching or pre-buffering that item. But as an application doesn't always know which item will be started, I think parallel pre-buffer is still very useful and gives a very good performance.
Awesome. If you delete a video node with a prebuffer, will that instantly delete the resources so you can pre-buffer another?
Yes, even just stopping the video node would also delete the resources.
Excellent. Let's keep waiting for more questions. Does the Roku video player support HLS interstitials?
The Roku video player itself doesn't support HLS interstitials, but we do have another library that wraps the video node and allows that. And this is going to get into the Roku Ad framework and then probably become public.
Yeah, so this is something perhaps that will be available down the road. Just stay tuned. When it does become available, we'll definitely announce it with more information, details on how to implement it. For the use case of pre-buffering videos, when a media item is hovered, is there a way to cancel a pre-buffer and starting another without stopping the player?
I'm not sure I understand the question. Typically, you have separate video nodes for each item. And so if one video node is playing and you pre-buffer another one, you can stop the one you're pre-buffering without it will impact the playing one. So that you can definitely do. Just give a stop command to the video node that was pre-buffering, and the playing one will just continue to play.
Arturo, just in case that didn't answer your question, you could use the raise hand feature. We could have you elaborate on air. All right, on to the next question.
Go on. Okay. So about the common state. So no, these video nodes do not share common state. So mute will be separate per video node.
Excellent. Great question so far. Oh, okay. Arturo has raised his hand, so let's see if we can get more, some more elaboration here on this. Give me 1 second, see if I can bring Arturo up. All right, Arturo, I'm going to allow you to talk. You can talk on air now. So Arturo, go ahead. Please elaborate on your question. Arturo, we need to talk about mic quality. Are you coming? Are you good now? Or no, it didn't work. It sounds like Arturo, whatever his
No, it's better.
That is so much better. Go ahead.
I'm so sorry. Every time I try to select a microphone, like 10 options appear. Sorry. So my use case is that I usually have a video playing not in full screen, so the rest of the application can still be interacted. And there is a list of other videos that the user can select. Also, I usually manage my video player content as a playlist. I've noticed that that allows the next video to pre-buffer automatically when the current one is about to end. So what I would like is that, while the current video is playing, hover in another item of the same playlist and start pre-buffering that. And I cannot stop the video because that would stop the current video that is playing.
So theoretically, if you remove the next item from the content list and add another one instead, then we should start to pre-buffer this next one. So when the current item will end rendering, it will automatically start playing the next one.
Yeah, that is what I see. But what is attractive for me about this prebuffer command is that it seems that I can manually specify the content that I want to start prebuffering and the moment where I want to do that. So that's why, let's say the user is hovering 3 videos ahead, and so if they continue hovering for like 2 seconds, I'm pretty sure that they're going to start playing that. So can I pre-buffer a specific element of the playlist in that case?
No. The only way to manually control what you pre-buffer is to have another video node.
Okay, thank you.